So the original plan was to use battery pack I made in my last video to power this car. So I went out and bought a brushed DC motor that was 24 volts, so the same as my battery pack. And I tried to figure out how to attach this motor to the wheels. So here's the first iteration. The reason I use Lego is 1, because it allows for super fast prototyping, and 2, because it's Lego, all the pieces are going to be pretty much the exact same. And if I had tried to 3D print them or to make it out of like popsicle sticks or something, then it would have been a lot less consistent and it would have been harder to iterate on my design. So I also used plywood that I cut into a shape that I based off my chassis design. We'll get to that later. And then I used zip ties to attach the Lego to the plywood. So later on, I realized that this setup was not actually strong enough to drive the car. The motor was spinning really fast, but it didn't have enough torque to actually overcome the friction of the car sat on the table or the ground or whatever and actually drive forward. Here's the thing with motors. You can change their output, the ratio between speed and power. And the way you do that is with the gears that you attach to the motor. So this is called gear ratio, and the basic idea behind it is that if you put a small gear driving a big gear, then your output is going to have a lot of torque or a lot of power. But if you put a big gear driving a small gear, then your output is going to be very fast, but it's going to be kind of weak. So basically what you can do is you can combine these different gears to get the necessary torque and speed that you want for your application. So because I decided to use Lego, I was a bit limited in what sorts of gear ratios I can make because there are only so many sizes of gears. So my motor and the gears that I had wouldn't provide enough torque for my car. So I went to get a new motor. This changed a bunch of things with my circuit, which we'll get into later, but in the meantime, drivetrain. So I swapped my motor and I redid the drivetrain. Getting the drivetrain working was actually one of the hardest parts of this project, but I eventually got it working and I eventually got it driving. But after I got this drivetrain working and I got the output to be as torquey as I need it to be, it runs into something called a differential. So a differential does 2 things. 1, my rotation was coming parallel to the car down the center of the car. That's not very useful because the wheels are out the side. So the differential helps me rotate that power 90 degrees to get it going out the sides of the car into the wheels, which is good. The second thing the differential does is it actually helps reduce the turning radius of the car. So basically, if both of my back wheels, which are the ones connected to the motor, are driving forwards, I can turn the front wheels, the steering wheels, however far I want. But the car's not actually really going to turn if both of the back wheels are driving forward really aggressively. It's just going to slightly drift to the right or the left depending on where the wheels are turning. But with a differential, I can actually hold one of the wheels in place. And that means that all the power is going to go to, in this case, the left wheel. And that means that the right wheel is going to stay stationary, but the left wheel is going to pivot around it, which would make for a much sharper turn. So after getting my drivetrain set up, it was time to attach the wheels to the car. So these are not Lego wheels, so I had to get a bit creative with how I attached them to the Lego pieces, which had different connectors. So what I did was I took a Lego gear and I used my soldering iron to melt down the sides of it so it fit inside of the wheel. Then I super glued it to the inside of the wheel. For the rear suspension, I used the strongest springs I had and just attached them directly to the car. This wasn't too complicated. The suspension was a bit stiff, but that's fine because the motor, the heaviest component, was right on top of it. The front suspension was a bit harder though because there was going to be steering at the front. The reason why this is a problem is because the body of the car is going to change relative to the height of the wheels. So first, let's back up a bit though. I use something called double wishbone suspension, which basically is just a fancy piece that you use that happens to look like a wishbone that lets the front wheels rotate freely. Okay, so great. Wheels can turn. Fantastic. Back to the problem with the suspension. I wanted to use a servo and a gear to turn my car. This is easier just to show you, so here you go. Basically, servo is controlled by a microcontroller, which then drives a gear, and that gear is going to push or pull a gear bar, which will drag the wheels back and forth, depending on whether you're turning left or right. The problem, if my car body is going down relative to the wheels, then my servo is going down relative to the steer bar, which would mean that the gear is no longer going to intersect with the servo, and therefore the car cannot turn. So it was at this point that I realized that my Lego was not going to cut it, and I applied it to 1517's Beach Grant. They generously supported me buying a 3D printer, which was super helpful because it let me print custom parts. So for example, I printed a ball joint that would let my steer bar move up and down with the car body. Now, moving on to the electronics. there were two things that this circuit needed to do to drive my car. It needed to control the motor, so turn it off and on, and it needed to control the steering. So I already kind of explained how the steering works. It's really just a servo and a gear, and that's not too complicated a wiring job. This servo is powered by this red wire here, which is connected to this 9-volt battery. And it gets its signal through this green wire, which goes to one of the pins on the ESP32. And then this black wire is just grounding it, so not too complicated to set up. When it comes to powering the motor though, that gets a bit more complicated. Originally, I planned to use something called the H-bridge, which basically gives you a lot of control over the motor. It uses 4 switches, and from that, it lets you turn the motor forwards or backwards, it lets you control the speed, it lets you stop it, lets you do a lot of fancy things. The downside with that though is that it is quite complicated. So I decided that, as interesting as the H-bridge was, I wanted to simplify my motor driver. It doesn't have quite as good control as the H-bridge would have, but I'm still pretty happy with it. It can make the motor go forwards, it can make it stop, and it can control the speed. So before I explain how this circuit works, I want to explain how I control the speed, because it's the same principle with both of them. So basically, both of these circuits, the H-bridge and mine, have a switch. In my case, I'm using a MOSFET, which is basically a voltage control switch. The idea here is that if you turn the switch on and off really fast, then you can control its average output. Let me explain a bit better. If I have on and off, so I only have 2 states, that's what digital means. If I turn it on for half the time and off for half the time, then the average output is going to be half of the maximum. So in this case, it would be 50%. And what I can actually do is by changing the ratio of on to off, I can control what the average output is. I can make it 20, I can make it 70, I can make it 80, I can make it 93 if I wanted to. And that basically lets me have continuous control over the speed of my output, or like the magnitude of my output, compared to digital, which usually only lets you have completely on, completely off. And this is called a pulse width modulation signal. So basically I'm using that and a MOSFET to control the speed of the car. It basically uses this ESP32 signal to turn on this chip, and then this chip amplifies the signal to turn on this MOSFET, and then this MOSFET will allow this battery to be actually connected to the motor and the motor to turn. So to expand a bit more, ESP32's output signal is at about 3.3 volts, which is not enough, because this MOSFET, to control this battery, needs to have a signal of around 10 volts. So what I've done is I've got this orange wire right here is coming from this battery, and it gets 12 volts. So then what's happening is this chip steps up this 3.3 volt signal from the ESP32 and outputs it to 12 volts. That 12 volt signal then turns on the MOSFET, and then the motor drives. So I'll also touch briefly on the batteries I used for this, because getting these right was another one of the most challenging parts of this project. So I had originally planned, like I mentioned, to use my lithium-ion battery pack that I made for this project, but that didn't work because I swapped the motor. So instead, I used alkaline cells for this project. So that's like your classic AA batteries. And I wouldn't recommend this for long-term use, but it's actually really great for prototyping. But what I did was I connected these alkaline cells to make whatever size battery pack I needed. I used tinfoil and electrical tape to connect these battery cells. So the idea here is that you can connect battery cells either in series or in parallel. If you connect things in parallel, you increase their capacity. So capacity is how much energy they can store. And the reason why this matters is because it determines how much current your battery can give. So discharge rate, or how much current your battery is outputted, is expressed as a fraction of capacity. So if I have higher capacity, I can output more current, and for a given current, it's going to put less stress on the battery. So for example, if I'm trying to draw too much current from the battery, then it might overheat, which would be bad. But basically, I use this to, in my case, connect 2 9 volts to get a higher capacity battery that could discharge the current needed. There's also cells connected in series. So I had a bunch of little 1.5 volt alkaline batteries, and I connected those in series to give me a 24 volt battery pack. The reason why I couldn't use my original 24 volt battery pack for this was because that one is super heavy, so that would be really hard for the car to drive. And I didn't actually need that much current draw, so it wasn't worth having the extra capacity that came with that larger pack. So because I used alkaline, I had problems with the current discharge, so the car doesn't actually drive very fast because the motor isn't getting that much current. And that's because lithium ion can deliver a lot more current than alkaline cells. So if I was to do this project again, then I would definitely use lithium cells. And I mentioned earlier that I'm using an ESP32, as my microcontroller, so a little computer on my circuit. The reason I picked ESP32 is because it has Bluetooth, which means that I can actually connect my phone directly to it and then control the ESP32, and that's the car, from my phone. Okay, if I send W and I can send S to stop it, and I can send right, the wheels turn, I can make them turn more, and then they stop. And then I can also send left and get the wheels to turn back the other way. This is so cool. Okay, so last thing, time to make it look a little bit less sketchy. So now we've come to the chassis. My friend actually recommended that I make a DeLorean for my chassis, which actually worked extremely well because in CAD, so 3D printing, computer-aided design software, it's really hard to make curves. So to make something like a Porsche would have been an absolute nightmare. But the DeLorean is mostly angles and flat edges, so it actually worked out super well. And my motor attachment is really big, and the DeLorean's motor sticks out the back, so it actually worked out very nicely. I printed this in 2 parts. The first one took 19 hours, and the second one took just over 24 hours, so a lot of printing, but I'm pretty happy with how it turned out. And I then spray painted it silver, and I added black trim for the windows and the underside. Running circles in the concrete. Revolving doors in my head, windows I can't see. This was a super fun project, and I had so much fun making it. I learned a ton about circuits as well, and about just engineering design process. And I glossed over a lot of the details in this video though, so if you have any questions, feel free to put them in the comments and I'll do my best to answer them. But yeah, thank you so much for watching, and I hope you enjoyed.